Welcome to this session. In this session, we are going to solve a problem on determination of residues of functions which can be written in the form phi of z over psi of z, such that the value of the denominator at 0 is 0, but the value of the numerator at 0 at A. So this general point A or the pole is non-zero. So solution for this function given by code z. So we say that we know that f of z given by cot of z can be written as cos of z over sine of z. That's the definition of a cot function. Okay, the other way around. Cosine over sine. That's what we have by definition. Now, since cos, okay, before we go to cos now, let's find the poles of the function. Now, the poles of f of z are the roots of sine z equals to 0, simply taking the denominator and equating to 0. And when you do that, sine z equals to 0 implies that z is of this form, n pi, where n is 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. So those are the values that will give sine of z to be 0. So residue of f of z at z equals to n pi, because these are the values that will give sine of z to be 0, is given by cosine of z over d dz of sine of z. Now, what is making us to use this law is because that in the original function, which was cos of z over sine of z, since in cosine of n pi is non-zero, but sine of n pi is 0. That's why we are saying that to find out the residue, we simply fix the numerator and then differentiate the denominator. So i.e. residue of f of z at z equals to n pi is given by, so, and remember this, we calculate the values at z equals to n pi at n pi. So residues are given by cos of z over, when you differentiate a sine function, you get a cos function. These are evaluated at z equals to n pi. And by definition, cos over cos is 1. So which is actually the same value when we evaluate at the point z equals to n pi. So hence, the residue of f of z given by cot z at its poles, actually which are given by n pi, is 1. So that's the solution. Thank you.